Today I'll be demoing how to set up a KSQL server and KSQL um, CLI in local environment. So let's do it. So I'm opening a terminal and I'm going to run a Docker image. So for this demo, what I did is like I download. I'm using the clickstream demo from KSQL. So let me execute this one. Okay, here in this demo, uh, the image was already installed in my locals. That's why it was very quick. Normally, if you're doing for the first time, it takes some time to download the required libraries. So and once it's installed, if you are executing it next time, it should not take that much of time. As part of next step, I'll export the Kafka heap ops. So normally, if you're running in Kafka, uh, there could be scenario like Kafka is taking too much of memory. So in order to stop that kind of behavior, what I'm doing here is I'm setting the Kafka heap ops max as 512 MB and mean as 256 MB. So this will help us to stop the negative consequences of out of memory or something similar. Next step, I will start the Confluent engine. So Confluent comes with a different component. It comes with Zookeeper, then Kafka, schema registry, Kafka Connect, Kafka REST. So Kafka's schema registry is is interesting. So schema evolution is an interesting thing. I mean, even if you think about how schema evolved from Excel to database schema to JSON schema or to Avro, right? So it's a pattern. It's an evolution that happened in last couple of years. Now, in normal Kafka world, uh, there will be a broker which will maintain the topics and all the other details associated the topic. There will be couple of producer on one side of that broker or topic, and there will be couple of consumer on the other side of the topic. So it's more of a typical pub sub mechanism, right? Now think about that in a topic, producer is now sending 12 attributes. Now all of a sudden you updated few existing attributes and then added couple of more. It can break the consumer world. So in order to handle this kind of scenario, what schema registry offers is like versioning the schema. So in that way, what we can do is like we can maintain the compatibility across the versioning. We can either maintain the forward compatibility or backward compatibility or full, and create different version from that schema and maintain that version in schema registry. Okay, now let's go and start an KSQL data engine data generator. So what this data gen does is it will simulate the weblog scenario. So in a giving an example in a production environment, or in a product in a website, normally user goes there, clicks couple of field, add few details, navigate to different page. All these details or user experience is captured by some analytical tool. Those information later send it to some other component so that it can extract some meaningful information out of this data set. Now this data gen will try to simulate that kind of information. It will generate like which IP user is actually browsing that, or surfing that browser, surfing that website, browsing that website, or doing some activity. What is the amount of data that user is actually sending? What is the timestamp? So couple of information like that, and then it will send those information to an different processes which will take those information and do some analysis on top of it. So this KSQL data gen will generate that kind of information. What it also do is like it will create an JSON out of those information, and then send those information as a JSON to this topic. The topic name here is like text stream. So the max interval and iteration details are for the data gen, how frequently, and what is that interval to generate those data. So let me start this one. It started. Now it's time to verify how the information is sending to this uh, Kafka topic. That is, the name of that topic is clickstream. So it's sending the information in a JSON. I'll take one of the you know mm, one of the record from here, or one of the JSON record set from here, and copy paste it somewhere here. So if I format this JSON, it will looks like below this one. So what it has is like remote user information, request, then referrer, agent, bytes, IP, time, user ID, and status. Now this as a JSON is going there in this topic, right? So we can consume that one using this Kafka, vanilla Kafka console consumer. So this is happening in the background. Next, what I'll do is like I'll start the KSQL server. KSQL server started. Now I'll fire the KSQL CLI. Okay. Now before firing that KSQL CLI, let's open this properties file and see what it contains. So KSQL server dot properties has a broker details, that is bootstrap.server, which is pointing to localhost 9092, and it's listen to 8080 port. Cool. Now I'll go back and start this KSQL CLI remote. So when I'm running that KSQL CLI, I'm saying that hey, give this listener information. So I'm saying it's remote, and giving that listener and port information. Cool, it's connected successfully. Now let me go back and discuss few item on the concepts. So KSQL CLI can be run in standalone mode or in client server mode. In standalone mode, everything is running locally, mm, and it's like very simple. Whereas client server mode is quite similar to the production environment, wherein the Kafka cluster is running across different machines here, and we have different KSQL server running in a different JVM instance. And then KSQL CLI is actually connecting one of the KSQL server. So that's how. So if I go back here, so when I'm firing that KSQL CLI, I'm giving that KSQL server listener information, and within KSQL server we have an broker details, right? So when a message is coming to Kafka broker, uh, the and if I run some query here, I'll be able to get that information through that topic. Okay, so next I'll create a click stream. Clickstream is a it's like unbounded facts. That means the information that is coming through Kafka topic is not mutable. So what we are doing here is creating a stream, and the name of the stream is like clickstream, and then it will take couple of information from the topic clickstream, and the value of that or the format of that information is in JSON. So it's basically taking the information from this JSON, which KSQL datagen is producing on that topic, and the topic name is like clickstream. So if you see the column details here in clickstream is like time, IP, request status. Those information are coming from this JSON topic: status, IP, bytes, time. Okay, so let's create this clickstream. Okay, clickstream is now created. Let me see what are all the streams that I have. Okay, I have only one stream which I created now, which I created just now, right? The click stream with name clickstream. Create stream, and the name of the stream is like clickstream. Okay, so let me do and select star from clickstream. So as I told earlier, clickstream or stream or KSQL streams are like unbounded facts. That means if I go back to this diagram, informations are or KSQL data gen is like sitting here somewhere here, and then pushing all the information like user, IP, status in a JSON format in a topic, and the name of the topic is like clickstream. And we created a stream which is basically pointing to that topic, and that clickstream is somewhere residing in this KSQL server. So whenever some message is coming to it to that topic name clickstream, the unbounded stream named clickstream getting those information and printing it here in this console. We can do some filter operation that we normally do in SQL, like select star from clickstream, where let's say IP like 33. I hope there are few IPs with 33. Let's see. Oh, it's not there. Or maybe it didn't get it. Oh, it's there, right? Okay. So for some time the IP was not like 3, and it started getting those one, right? So if I run the other one, yeah, I'm getting the results. So all good so far. So I created a stream. Now what I want to do is like created a table from that stream. So in the first, I mean the earlier statement, it was like I was creating a stream named clickstream from the topic clickstream, right? In the next SQL, what I'm doing is like creating a table from a stream name called clickstream. So the stream is created here. Now stream is getting all the information, right? And I'm creating a table from that clickstream. Now the obvious question will come: what's the difference between stream and table? As I was discussing earlier, stream is more of an unbounded facts. It's like not mutable. However, table is like evolving facts, and that is mutable. Uh, so you can think about table is maintaining the status, whereas clickstream is more like stateless. It's like it doesn't change anything. It's like it's coming, it's printing, and then it doesn't do anything else. Whereas in table, if we have an information against some primary key, like user ID or something like that, and if the same information is coming after some time, the previous information will be updated. Let me create this table. Table creation is down. List topics. Cool. I can describe either clickstream or a table. Right. And I mean, I can also do something similar, like I can create a table from a table and adding some more information. So that's what I'm doing next. So now one more table is created, and if I do and describe, so I can see the row time is actually added here. So in my next, so I created an first I created a table called IP sum, and then I added one more column and created a different table called IP sum TS. And the new column in the second query, or the last query, was like the row time that I added. So row time is coming here when I do and describe on IP sum TS. That's all. Uh, we can we can export this data in an Grafana server, so that we can see a nice dashboard, but that is something outside the scope of this demo. uh, because what I thought is like, I'll be demoing how to install the KSQL server, KSQL command line utility, and do some basic SQL operation using the KSQL CLI. That's all. Thank you.